Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the velocity of efflux in the case of multiple liquids. So just imagine this case in which there are multiple liquids which are filled in this beaker, and out of them one of the liquid is coming out from a very fine small orifice. So we have to find out the velocity of efflux of that liquid. So first of all, let us see that we'll be applying Bernoulli's theorem, and to apply the Bernoulli's theorem we should know the pressure at this point A, the pressure at this point B, and the pressure at this point C. So pressure at A obviously will be equal to P naught, and pressure at B will be equal to P naught plus, now this is H1 rho 1 G. So this is H1 rho 1 G plus this will be H2 rho 2 G plus, and this will be small h, let's suppose it is small h rho G. So plus small h rho G, rho 3 G. Okay, and the pressure at C will be equal to P naught because this is just outside the container. So the pressure at C will be equal to P naught. So we will be applying Bernoulli's theorem on B and C. So PB plus half rho VB square will be equal to PC plus half rho. Now if we are making a general formula, then we'll be writing rho out instead of rho 3, but at this moment of time let us write down rho 3 only. So rho 3 V, or let us write down rho out. Okay, the density of liquid which is coming out of the container. Now when we will substitute the value of PB here and the value of PC here, then P naught will be cancelled out. So, and we also know that for this condition, when the cross sectional area of orifice is very less than the area of the container, then in this condition VB will be 0. Okay, VB will be negligible. So we can say that H1 rho 1 G plus H2 rho 2 G plus H rho 3 G will be equal to half rho out is rho 3 VE square. Okay, and we can also write it down as summation I is equal to 1 to N HI rho I into G and into 2 also divided by rho out and under root of this term. This is called as the efflux velocity in the case of multiple liquids. So you can also memorize this formula. Thank you.